Our topic for today is how to solve quadratic equations using completing the squares. So we have an example, x squared equals 49. First method we are going to use is the one we studied last video, the factoring. So in order to do that, let's move 49 to the left side of the equation. So we have here x squared minus 49 equals 0. Then you can factor this using the difference of two squares. This is a perfect square. X squared is a perfect square and 49 is a perfect square. So we can have x plus 7 times x minus 7, or the sum and difference of two binomials equals 0. Then by 0 factor property, we can have x plus 7, first one, equals 0, and x minus 7 equals 0. So since this is a plus, moving this to the right side of the equation or transposing this to the right side of the equation becomes negative. So x is equal to negative 7. And this is a minus. So moving this to the right side of the equation or transposing this one, it becomes a positive. So x equals 7. So for positive 7, we have two values of x. First one is negative 7 and the other is positive 7. So we can write this one, our result, as x equals plus or minus or negative or positive 7. And in the second method, let this stay in the original equation, x squared equals 49. Notice here that x squared is a perfect square and 49 is a perfect square. So we can directly extract the square root of both sides of the equation. If you get the square root of the left side of the equation, you must also get the square root of the right side of the equation. So the square root of x squared equals the square root of 49. And this is equals to x equals plus or minus or negative or positive or negative 7. So the same value. So we have here also x squared minus 8x plus 15 equals 0. And this is not a perfect trinomial square. So we are going to make this equation, both sides of the equation, a perfect square. So let's first transpose this 15 to the right side of the equation, making this negative. So x squared minus 8x equals negative 15. So in order to make this left and the right side of the equation perfect squares, we are going to add a number here. And that number is from this one, the middle term. You remember that in a perfect trinomial square, the middle term is twice the product of the first term and the last term of the binomial. So there is a 2 here that is being multiplied. So let's get the 2 here. So 8 divided by 2, and this is equals to 4. And this 4 here, we are going to square the 4. So this is equals to 16. And this 16 is the number that we are going to add to both the left side of the equation and the right side of the equation. So x squared minus 8x plus 16 equals negative 15 plus 16. And if you add this one, this becomes 1. So x squared minus 8x plus 15 equals 1. Notice that this one here is a perfect square, and also 1 is a perfect square. So factor this out into binomial square. So the square root of x squared is x, and the square root of 16 is 4. And since we have a negative sign in the middle term, so this can be factored as x minus 4 squared equals 1. So we have here a perfect square in the left side of the equation and a perfect square in the right side of the equation. So extract the square root of both sides of the equation. So the square root of this side can be cancelled by this square in the x minus 4. So, and this one is equals to 1. So we have here x minus 4 equals plus or minus or positive or negative 1. X minus 4 is equals to plus or minus 1 or positive or negative 1. And we can have the two values of x here. We have x minus 4 equals 1 and x minus 4 equals negative 1. So solving this one first, transposing 4 to the right side of the equation, since this is a minus, this becomes a plus here. So x equals 1 plus 4, and this is equals to x of 1. Our first value of x is 5, and this one here, let's transpose 4 minus 4 to the other side. So this becomes plus, so x equals negative 1 plus 4, and negative 1 plus 4 is 3, so x of 2 is equals to 3. That's how we solve the values of x using the completing the squares.